All right, hello everyone. Welcome to Hangout on Air about the Google Maps Engine API. And today we're going to be talking about a store locator type of implementation. First, some introductions. My name is Dylan Thomas. I work on the Geo Enterprise team here at Google. And with me is Dave Overstrom, who's on the same team. Hi, Dave.
Hey Dylan, how you doing?
Good, thanks. Unlike the last live event, we are not sitting next to each other. So if I do that, I'm not looking at Dave. He's in New York. So thanks for joining us. And as I mentioned, we're going to be talking about the Maps Engine API. And Dave is going to start doing the presentation. Before we do that, for those of you who are joining us live, if you would like to leave your questions on the G Plus page for this event, please do so, and I'll scan them and I'll read them out as we get them. And if you're joining the event after the fact, if you're watching a recording, you will have seen a summary of the questions and answers in the Geo Enterprise community. So with that, take it away, Dave.
All right, thanks Dylan. So like Dylan was mentioning, my name is Dave Overstrom. I'm part of the deployment team for Geo, based in the New York City office. And today I'm going to be talking about Maps Engine and store locators. So last week I know you had a nice presentation from my colleague Alan Poole around OAuth 2. So this should be a nice kind of addition. We're going to not cover OAuth 2 in that much detail, but we're going to kind of use what we learned from that hangout last week and use it to actually build a store locator type solution. So like Dylan mentioned, if there's any questions as we go through this, feel free to enter them in. To start out with, I just want to quickly give kind of the reasons why you might want to consider Google Maps Engine for a store locator type solution. One of the first is that it's actually built on the exact same infrastructure that's powering maps.google.com. So, your application is going to be using the exact same hardware, CPU power, and kind of delivery network that is hosting maps.google.com. So you'll have best-in-class performance, scalability, a really, really powerful infrastructure. Another kind of benefit for Maps Engine is that it can reduce your system complexity and even cost. So, rather than having to stand up your own server environment and host, geospatial databases, front-end servers, you can actually use Maps Engine for all of this. Coupled with the fact that you have Google App Engine that you can use for hosting any kind of client-side or server-side code, it's a great kind of way to get directly into the cloud and start using Google's infrastructure for your application. A third reason is that it's the enterprise alternative to Google Fusion Tables. So for folks on the call who have actually leveraged Google Fusion Tables, it is a consumer product where you can essentially store a small amount of geospatial data and visualize that. Maps Engine is kind of the next step, right? So we're basically giving you an enterprise offering. You're able to host thousands of features and serve that up really quickly. And then finally, we have an API. So Google Maps Engine has its own API that you can use to do full create, read, update, and delete commands. And I'll be talking about that as we go through the presentation today. Okay, real quickly, I want to cover some of the high-level architecture that I'm using for the store locator solution that I'll be demoing shortly. As you can see on the left-hand side here, we have your typical three-tiered architecture with client, application, and database tier. On the client tier, we're actually using kind of our Google Maps API for business. So you can see that there's Google Maps JavaScript API v3. It does communication directly with kind of the Google services out in the cloud. It's also, on the client tier, you'll have all of your HTML, JavaScript, CSS for styling. You'll use this to actually interact with Google Maps Engine, and there's a couple ways that you can do that. One is we have a Maps Engine layer that you can add directly to your Google Maps JavaScript API v3 application. So with just a few lines of code, you can add a layer from Google Maps Engine and visualize that on the map. All the tiling is actually done server-side on the Google Cloud. So the benefit here is that you're not having to pull down a lot of features, and you're able to visualize it directly in your client application. Besides the Maps Engine layer, there's also the Maps Engine API. So with this, you can query features and then also do read, update, and delete type commands. So we'll use that within the application to show how you can actually update store location data through the API and have that basically to be displayed and updated real time. I have a little note on the right-hand side here that if you wanted to leverage Google App Engine, you can use that to host all of your HTML, JavaScript, Java, Python code, which basically removes the need for any type of internal server infrastructure. So, basically get all of your code into the Google Cloud and leverage Maps Engine for all of your geospatial visualization and query needs. As far as updating data within Maps Engine, there's a few different techniques that you can do. One is for your store data, you can do a full data replacement, right? So you can essentially delete all the store records and have a little script that just updates all of the stores with the new data. The benefit here is that you're essentially creating a really simple script that just does a full delete and then basically does an insert, so you're getting all of the latest and greatest data. One watch point for this is that if you've got a production database, you obviously don't want those stores to be removed while you're doing the delete and update. So what you'll have to do within your kind of your architecture is design it in a way that you have two tables. One which would be kind of the live data that you would have your application point at, and then you would have a kind of temporary data database table that you would sync these changes with. And then when you're actually when you're actually updating the live data, you would swap your application to point to that temporary data store, over those few minutes while the records are being updated. Another method that you can actually use is an incremental data replacement. So with this, what you're actually doing is maintaining timestamp information both for when that data was modified and when the last sync occurred. And this allows you to basically modify only records that have been changed. So you're essentially just syncing the changes or the deltas within